Normally, what dies tends to stay dead. But in the case of galaxies, some rise up from the dead, becoming zombie galaxies. This is their story. For 20 million years, galaxy A2744-YD4 lay dormant, a celestial corpse drifting through the early universe. Without star-forming material, its star production had ceased long ago, making it a lifeless relic of a once glorious past. Yet seemingly, against the universe's natural order, it sparked back to life in a spectacular burst of star-making fury. An astonishing resurrection, marking it as a zombie galaxy, and the first evidence we'd ever seen that dead galaxies do come back to life. To understand the full significance of A2744-YD4's astonishing revival, we need to delve into its origins and the cosmic conditions that made a dramatic turnaround possible, and discover why it is reshaping our view of galaxy evolution in the early universe. Shortly after the Big Bang, the universe was a chaotic sea of hot plasma, gradually cooling and expanding. Amongst the primordial turmoil, tiny fluctuations in the density of matter began to form. Within one of these dense regions, dark matter clumped together, creating a gravitational well that started to attract hydrogen and helium, the building blocks needed for stars and galaxies. As the gas cooled and condensed, it formed a protogalactic cloud, and over time this cloud began to fragment into smaller, denser regions, where stars ignited, and with them the galaxy A2744-YD4 began to take shape. Young hot stars formed, illuminating the surrounding gas and dust in the tinged blue light typically emitted by young stars, giving birth to a vibrant and dynamic star-forming galaxy, with A2744-YD4 being one of the earliest in the universe. Over the next few hundred millions of years, this galaxy experienced rapid growth, merging with other smaller protogalaxies whilst accreting more gas. This period of intense star formation was punctuated by the violent deaths of massive stars, whose supernova explosions enriched the surrounding gas with heavier elements, setting the stage for future generations of stars. It's an initial burst of activity that didn't last, as the galaxy's star-forming material was gradually consumed and depleted as new stars formed. Supernova and strong stellar winds ejected much of the remaining gas out of the galaxy, while the intense radiation from the young stars ionized and expelled the interstellar gas needed for new star formation, whilst the growing supermassive black hole at the center played a crucial role in emitting powerful radiation in jets that further disrupted and expelled the surrounding gas. As a result, A2744-YD4's gas reserves dwindled, slowing star formation and leading the galaxy into a prolonged period of dormancy. For 20 million years it drifted quietly through space, a once brilliant star-forming galaxy, now lifeless in the glow of its aging red-tinged stars. Yet the story of this galaxy was far from over. Gravitational interactions with neighbouring galaxies and the accretion of fresh gas from the intergalactic medium under the influence of gravity eventually reignited the engines of star formation. In a dramatic and unexpected twist, it sprang back to life, a true zombie galaxy rising from its cosmic grave, as a blaze of new star formation took hold. The tale of A2744-YD4's cosmic resurrection came to light through images captured by the James Webb Space Telescope. Observing the galaxy as it appeared just 650 million years after the Big Bang, astronomers detected an unprecedented phenomena. The galaxy displayed a duality never before seen, a mix of brilliant blue-tinged young stars alongside fainter red-tinged older ones. This unexpected demarcation between the two stellar populations suggested it had undergone a period of intense star formation, followed by prolonged inactivity or dormancy of about 20 million years, before reigniting back to life with renewed vigour. It hints at the possibility of cosmic mergers with other galaxies, which could have rekindled its star-forming engine when new star-forming material became available, or the cycle of gas expelled by supernova explosions eventually fell back under gravity to fuel a second wave of star creation. It's a behaviour that does not fit with our current theories about early galaxy formations, where the prevailing idea suggests steady and consistent star formation. Instead, this galaxy seems to be telling us that the earliest galaxies experienced dramatic bursts in star formation, followed by lulls in activity shortly after the Big Bang, suggesting that even in this chaotic early phase of the universe, complex processes like mergers and gas recycling were already influencing the evolutions of galaxies. A2744-YD4's journey from death to rebirth embodies the essence of zombie galaxies, demonstrating that in the cosmos even what seems to be lifeless can stir once more. It's a revival that reminds us that the dead can teach us much about life cycles, offering profound insights into the dynamic and ever-changing nature of the universe.